Hello everybody. Now we are entering into the sixth module of the course. In this module, that is the sixth week, we will discuss various aspects of juices and concentrates. So, in today's lecture, we will study juice extraction and clarification. The concepts or topics which we will cover in today's lecture include juices and their types, juice extraction technologies, how the juices are separated, what are the various novel and emerging technologies for juice extraction, and finally, we will also discuss about the clarification of the juice, which is another very important in the juices manufacturing. So, let us understand what juice means. It is defined in the most general sense as the extractable fluid containing of cells or tissues. According to the Codex Alimentarius Commission definition, unfermented palatable juice intended for direct consumption is the liquid obtained by mechanical processing of fresh or suitably treated sound ripe fruits which are preserved extensively or exclusively by physical means. And you know, fruits and vegetables are rich sources of minerals, vitamins and antioxidants, and therefore, these juices becomes a very good source for supply of these and these bioactives and vitamins and antioxidants etc. to the people. Okay. So, these juices, they are known among the people for their refreshing character, sensational flavor and rich nutritional profiles. Okay. Types juices may be classified into various groups depending upon the dispersion system's composition. Okay. That is, one category of the juice is clear or clarified or fully transparent juice, that is a water solution of the so called soluble solids which are present in the fruits or vegetables like sugar, organic acid, salt, free amino acids, water soluble vitamins and pigments etc. So, these are all water soluble components. So, you can say a clear transparent solution of all these natural components present in the food. Generally, particle size of these clear or clarified transparent juices is under 0.001 micron. Second category may be opalescent or translucent beverages, translucent juices. Here, that in addition to the soluble solids are clear juice, this type of juice may also contain certain colloidal substances with a distribution spectrum of maybe 0.1 to 0.001 micron. This dispersed phase includes pectins, hemicelluloses, proteins, protein polyphenol complexes and other dissolved starches etc. That is, some insoluble or maybe that colloidally dispersed materials. Third category may be a cloudy or turbid juice. This is actually an unclarified juice, that is pressed juice that is not subjected to any clarification treatment. Particle size here, it may be particle diameter may be less than 0.25 micron, most frequent diameter may be 0.6 to 0.8 micron. However, to improve cloud stability, that is the coarse particles which are generally unstable and prone to rapid sedimentation, they are partly removed by some physical methods like centrifugation etc. Then another category, or you can say last category of the fruit juices may be pulp enriched juices, and these type of juices contain a distinct amount of coarse cloud particles, that is sometimes even pulp particles with a diameter of over 100 micron, which are mostly fruit flesh segments like juice sacs of the citrus fruits, endocarp and so on. Okay. So, here the process flow chart for preparation of the juices, like preparatory treatment like harvesting and storage, raw material delivery system, reception, washing, conveying, stem elimination, sorting, peeling, cutting, or de-seeding and chopping. So, these are the preparatory steps for juice manufacture, and all these steps details we have already studied in earlier lecture. Okay. So, these prepared chopped minced material, it is subjected to next treatment which may be pulping, extraction of juice, clarification, maybe clarification through centrifugation, ultrafiltration, etc. And then finally, these prepared and clarified juices may be further subjected to shelf life extension treatment like degassing or pasteurization, or finally blending or packaging, etc. So, in today's lecture preparatory treatment we have already discussed earlier, and post extraction and post clarification treatments we will discuss later on. In today's lecture we will mainly concentrate on the extraction and clarification of the juice, which including pulping, that is pulping, extraction of juice and then clarification of the juice. So, let us see juice extraction. In this process, the liquid phase of the fruits or vegetables is expressed from solid particles, okay. And this involves obviously the size reduction like crushing, grinding, squeezer type extractor, or then separation. So, the first the material is made into some, it is crushed or maybe of a smaller size, and then from this crushed or ground materials, or which we call sometime pulp, then this is squeezed, or this is juice is separated from this pulp or ground material, okay. And for the various setups or equipment which may be used for the separation of the juices include pressure, rack and cloth presses, hydraulic presses, screw type presses, belt presses, hydro-diffusion press, or spiral filter press. And finally, these juices are sent to some other processes of like centrifugation, membrane separation, enzyme based clarification, or even sometimes fining agents are used to clarify the juices. So, let us study little details of all these processes like crushing and milling, that is basically convert to get the pulp, okay. Crushing or milling improves the distribution of fruits cell, providing channels for transfer of the liquid, because our purpose is to get the more and more amount of water which is already contained in the cell shape to express it out, take it out, and along with the water soluble components, nutrients or bioactives which are present in the juices, fruit material, they should come out in the cell shape. So, an array of machines have been applied to chop, crush or mill fruits to appropriate particle sizes, okay. But there are that is one has to take care, that is while pulping it or making it to the particle size, that pulp, that is appropriate particle size. This is very important, because if the particle size is too less or it is too big, both may be problematic, okay. So, the problems generally with the too finely milled pulp include, that is the difficulty in filtration. If it is the too fine, there is a increase in the percentage of suspended solids in the juice. Also, higher amount of these solids can result in better or undesirable taste, or bitter or undesirable taste. Even presence of pectinases and other degrading enzymes might be there, which can create further problem during storage, like insolubilization of pectin and separation of serum, etc. The problems with the pulp with large fruit pieces, etc., they result in relatively lower yield, and also the amount of suspended solids becomes low. So, the various methods which are used for side reduction of fruits include grinding, chopping or cutting, heating, and then hammering and milling. So, some of the important methods for preparing pulp, let us discuss little in detail. Like crushing mill is the one you can see here in the figure. This is used for crushing the fruit into pulp. It consists of sharp knives, as you can see here in the figure, are blades which rooted on a rotating shaft to cut the fruit into fine pieces. That is, crush the fruit in these machines crush the fruit in a few seconds and tilt periodically to discharge fine pulp into the feeding unit of the pressing machine. Crushing or grinding time is decided by the texture of the fruit and the required quality of the final juice concentration or final types of juice material required. The rotational speed of the shaft, temperature and moisture levels are controlled through automatic control system. Most of these equipment are provided with that, and these types of machines are better suited or they are used to cut soft fruits of fairly large size such as apples, pear, pineapple, guava and mango. The other type of mill is the grinding mill. You can see here in the figure, this consists of blades or hammers mounted on a spinner that rotates alongside a perforated screen. The speed of the hammer and the pore size of the screen may vary with the nature of the fruit and the quality of the intended juice product. These type of crushing machines avoid crushing of pits during maceration. Finally, the fruit mass is conveyed to the pressing unit, which minimizes the residence time of fruit mass in a buffer tank. Then these type of machines are used for fruits having fleshy parts such as strawberries, blueberries, black currants and grapes. Squeezer or extractor, you can see this is another type of it is a commonly used extractor, that is it comprises of an upper and a lower cup which you can see here in the figure, okay, and also they are provided with strainer tube and the cutter. The upper cup is lowered onto the lower cup with building pressure on the fruit. The fruit is put in the lower cup, then upper cup is lowered down and which builds pressure on the fruit. A cutter comes up through the center of the lower cup and cuts a hole through the skin in order to allow the inner parts to flow out. The upper cup continues to squeeze down on the lower cup to extract as much juice as possible. The pulpy juice flows through the strainer in the tube, okay, into the juice manifold. Eventually, the downward pressure causes the peel to break up, disintegrate and oil releases from the peel, and then you see there oil emulsion is coming separately. So, you get oil emulsion and this juice, pulp juice, separate juice remains here in the inner part. Okay. So, this is a special and a specific type of extractor for the used for generally extraction of the citrus fruit juices etc., where you can separate citrus oil emulsion as well as juicy pulp. Then now once these are chopped and you have got pulp etc., or minced material, then next becomes the separation of the juice from this pulp or from the chopped material or ground fruit pieces. So, for the separation there are various different machines. One is the pressers. You can see here these pressers belong to the frequently used classes for the juice separators. Okay. Their efficiency depends upon the nature of the porosity of the pulp, viscosity of the juice and extent of pressure applied. Pulp having sufficient porosity or sufficiently porous mass are spread evenly in a thin layer so that the juicy liquid has to travel a short trajectory to the facade. Sometimes the pulp is mixed with the water which disperses the semi-permeable membrane and facilitates the flow of the juice while dissolving a large amount of solid. So, a diverse range of presses have been designed and applied to express juices from the pulp mass. Okay. So, there are the one such category is the rack and cloth press. You can see here the assembly is shown in the figure. the picture. So, it is one of the traditional ways to extract juice from fruit pulp. Okay. That here what is done, that is the fruit pulp is piled along inside the mass hardwood or stainless steel frames or beds. It is entangled in loose cloth or nylon screens. Then topping the frame, over frame, that is one above the other, 3-4 such frames may be put together in several layers and they are formed, and then finally on the top pressure is applied, pressing of the sacks to evacuate the fruit juices. Okay. So, this is a most commonly used system, but it has drawback that this method is laborious and it lacks automation. Then hydraulic presses, they are another types of presses which are commonly used. Okay. Hydraulic presses are often used for pressing pulps of grapes, berries and black currants. Pressure causes fruit cell to vacuoles to burst, liberating natural bioactives, enzymes and minerals. So, what is done here? That is mass from the continuous milling units, that is from the pulping units. It enters in the, you can say, in first of that bottom in the pressing unit, okay, and where the pressures of about 6000 psi is applied via an adjustable piston and sufficient water is added to re-extract the juice obtained in pomace. So, resultant juice passes through a fine wire screen made of corrosion free materials or muslin bags, and then finally the juice is stored, sent for packaging and storage. Then screw presser is another machine used for separating the juices. Screw presses are the traditional devices. They are cylindrical vessels, you can see here in the figure, with screw type press mounted on perforated screening assembly. But recent designs are automated with several assemblies of screw presser in continuous mode. So, this system has one major drawback, that is fruit juice like apples, pears are more prone towards oxidation when they come in contact with the metal like such an iron etc. of the screw. Okay. So, our continuous screw presses require pressing aid, often cellulose up to 1% by weight, which may result in off flavor development. So, what is the possible solution? That is, these metallic screw presses may be replaced by nylon or wool based press cloths, which are lighter in weight, have greater strength and useful life, and they are very easy to even clean. So, this can make this system is even more versatile. Then belt presser, see that is assembly is shown here in the figure. These presses offer juice yields of about more than 90% and have become part of the juice manufacturing unit. They are extensively being used by the industry. So, fruit pulp is spread on the nylon screen, is pressed under the couple of rollers, you see that different rollers. So, it is the pulp is pressed and which expresses the juice and the pomace. That is, so the process involves the spreading of fruit pulp continuously and evenly on the bottom screen by automatic spreader, covering the screen by an upper belt, okay, and then guiding the screen to the pressing unit driven by heavy rollers. Okay. And from here you get the juice flows out of the leaving pomace behind, and then this pomace may be further down into the next belt, pressing of the pomace at increased, where it is pressed at increased pressure by the rollers of reduced diameter, and this removes further, that is the traces of the juice is extracted. So, from this type belt pressures one get more recovery of the juices. Then another process is the hydro-diffusion extractor. It is the mechanical pressing system which suffers from drawback of low juice yield and reduced insoluble solids. Diffusion extractors are used for continuous counter current extraction of juice from apples etc. water soluble fruit cells components are continuously transferred to aqueous solution through semi permeable cell membranes. Okay. So, typically these diffusion extractors are suitably inclined cylinders which are equipped with helical screw conveyor, filtration screen, water injet system, pulp pumping machines and temperature, moisture and pressure regulating and maintaining units. Okay. These process gives better higher juice yield, they give the higher amount of soluble solids in the juice, but the juice is dilute due to the extraction water present there. Juice may be sour due to the tannins might be getting extracted in the juice, and this requires more energy and labor, okay, in the subsequent drying step. Okay. Then spiral filter press is another industrial unit or commercially applied unit by the industry. Okay. In this, mass from the mill or grater is sent to the buffer tank. The screw pump transfer the mass to the extraction cell, which you can see these are the screw caps etc. pumps, and mass in the extraction cell is lifted by a spiral screw conveyor, okay, and ascended continuously through the extraction cell. Rotating spiral causes juice to pass through an extraction filtration arrangement, and juice is transferred to storage vessel by vacuum pumps. So, such processes are useful for fruits like apple, pear, pineapple, kiwi fruit, banana and watermelon. In this method, Hamilton, that is which is a general German spiral filter machines is generally used to extract the juice from the fine pulp. Then these were some of the juice commonly used juice extraction and separation technologies, but let me tell you, most of these mechanical pressing techniques, that is when they develop press, at the same time they also develop temperature. So, this requires that this sometimes causes that some of the bioactives etc., nutrient sensory characteristics, that is adverse effect on this. So, the mechanical pressing techniques for juice extraction, however, may lead to increase in temperature of the juice, and this increase in the temperature of the juice results into loss of nutrients and bioactives due to thermal degradation etc., and also the cell rupture in mechanical pressing is poor, which results in the low juice yield. So, to overcome this low juice yield, hydro-diffusion techniques has been used for better extraction. However, this hydro-diffusion leads to dilution of the juice and it may result in the sour taste due to extracted tannins etc. So, what is the solution? That the techniques such as ultrasound, microwave and pulse electric, that is novel technologies, may be used to assist or in the as a pre-treatment for that juice extraction, and this has offered a better alternative for the juice extraction, that is the juices with good quality of the nutritional quality, sensory characteristics and even its bioactive composition. So, one in such novel technology is the ultrasound assisted extraction. You know, that is ultrasound generate cavitation bubbles in a liquid matrix which collapses simultaneously, causing extensive mass transfer, mechanical stress and thermal effects such as those of bubble disintegrate. And because of this extensive mass transfer, when you ultrasound, this causes cell ruptures and this facilitates more retention without much generation of the temperature etc., much generation of the pressure. You can, so ultrasound treated the cells, so cells are ruptured, and when this just by simple application, simple pressing, the juices are extracted, you get better yield and also you get better bioactive components in the juice. Then similarly, the microwave assisted extraction, it also does almost a similar work, that is when microwaves, when these fruits juices they are subjected to microwaves, that molecules that is orient themselves in direction of electric field. During relaxation, molecules get back to disordered configuration, while releasing thermal energy. So, in this technique, fruit or plant samples swiftly heat up from the interior and expands, which formally rupture to cause heat and water to burst outwards. So, microwave assisted extraction is an attractive technique for producing juices rich in bioactives like polyphenol, anthocyanins, antioxidants, etc. It has been suggested as a green alternative to mechanical pressing and enzymatic maceration. Then PEF, pulse electric field assisted extraction, this is PEF also, this PEF treatment leads to electroporation of fruit cells, facilitating the extraction of cellular bioactive. So, before putting the fruit to normal pulping and extraction process, if it is given a little PEF treatment, then it may result into the better yield as well as a better sensory characteristics, better bioactives. So, these offer good alternative to juice extraction. So, now after the extraction, let us now study the clarification processes, that is when these juice extracted using different methods which we discussed earlier. They are usually turbid due to presence of insoluble plant particles like fiber, cellulose, hemicellulose, protopectin, starch, lipid, etc. And also there are some colloidal macromolecules like pectin, protein, soluble starch fractions, certain polyphenols, and they are oxidized or condensed derivatives. So, depending upon the type of the pressure used, type of the machine used, and pressing and separating conditions, these components may be present into the juice. So, depending upon the finished product, desired characteristics, these substances must be partially or entirely eliminated to avoid turbidity and precipitation during storage as well as to improve sensory attributes. For this purpose, physical and enzymatic treatments have been applied to ensure clarity and homogeneity of fruit juices. So, one such is the simple decanter type centrifugation machine. It separates the suspended solids from liquids and slurry. It works based on the buoyancy effects, that is when juice is rotated, components with larger density fall to the bottom of the liquid extract. So, liquid part that is less than 1 micron passes through the screen and juice outlet, it comes to the solids of the larger mass, they are pushed towards the opposite end with a smaller conical diameter and they are pressed there separately. So, this is but this system, for any system, this system also has some drawbacks, some advantages. Drawbacks are it is high energy consumption, high equipment cost, high maintenance cost, unable to separate cells and viruses, but it is a advantage in the clean environment, flexible designs of versatile fruit juices, high throughput efficiency, and juice of even composition can be obtained through this. Then there is another is the disc stack centrifugation machine. This is the similar to that which is the cream separator used for the separation of cream from the dairy or milk. So, separation in the disc stack centrifuge takes place in the spaces created between certain discs which are here, number of conical separation areas, and most these of the model they rotate at a speed between 4000 and 10,000 rpm, and the accumulated solids can be discharged without stopping the centrifuge by rapidly opening an annular slot at the periphery of the rotated bowl. So, the clarified juice, it leaves the centrifuge under pressure and the pulp etc. It goes on the top and the separate into it. The clarification by centrifugation often leads to improved operation of the evaporated system by providing consistent pulp in the juice. Then filtration, normal filtration process like this is dead end conventional filtration, like one can have that is cloth, muslin cloth, filter bed, or even some membranes etc. It removes the particle size of the diameter larger than 1 to 20 micron, and after filtration medium saturates, washing and mechanical cleaning of the cake layer is needed. Then membrane filtration system can also be used. Here normally polymeric membranes are used, okay. That is a reverse, it removes the smaller than 0.1 micron particle size. Ultrafiltration techniques are used generally, in which the juices are allowed to flow over a membrane under pressure, okay, and this support the tube to avoid binding of the filtrate system, and then these solids which are suspended there are colloidally dissolved, they are retained on the membrane and the juice is permeate. So, you will get both permeate and concentrate goes out. This can be used also for the concentration. Then also the enzymes are used, that is use of pectinases to reduce viscosity and enhance extraction yield. It is common in the fruit juice industry like indo-polygalacturonases reduce viscosity of papaya juice by 17 to 18%. Pectinases are favorable for maceration of fruits that are rich in pectin. High temperature may deteriorate nutrients and accelerate microbial contamination. Therefore, enzymes offer high specific activity and lower temperature are more practical. Enzyme traces are completely removed by washing to avoid any odd constituents. Okay. So, but these enzymes, the juices may be treated with the enzymes, and these enzymes, what they do, that is the suspended particles etc., and whatever that is starch particle, pulpy particles etc. So, these enzymes they eat away those particles, they degrade and the larger biomolecule polymer into smaller one, they solubilize them, and also in the process the juice gets clarified and juice also gets even better, that is yield is also increased. So, even the incubation of plum fruit with 5 milligram per 100 gram pectinase at 37 degrees Celsius for 360 minutes increased juice yield up to even 92 to 93%. Mixture of pectin with ethylesterase and polygalacturonases at 50 degrees Celsius for 120 minutes produced about 97% juice yield. So, the commercial pectinase is available in the name poly-1,4-alpha D-galacturonase. It is the sources of this commercial pectin is Aspergillus species or Rhizopus species. Its operating pH is 2.5 to 6 and operating temperature is 30 to 60 degrees Celsius. Okay. So, in this slide just I have given you different enzymes, because that is one must understand that what are the nature of the particles and materials which are present in the juice. They may be pectins, they may be starches, they may be protein molecule, they may be some lipid molecules etc., depending upon the type of extraction that is used. So, accordingly the various enzymes like esterases or depolymerases, pectinases, amylases, cellulases etc., they individually or their mixture can be used in proper proportion, and which they degrade these substances, which clarify the juice as well as result in better juice recovery. Another method of clarification which is used by the industry is the use of fining agents, that is both physical fining agent or chemical fining agents are used. In physical fining agent generally that is includes the physical or mechanical action are kaolin, diatomaceous earth, Spanish clay, bentonite or China clay. They are known filter rates. So, generally 0.5 to 0.1% of the earth or these materials is mixed with the fruit juice and then passed through the filter presses. So, they take away these materials, absorb the various material that this is process. Okay. But the one thing is this, with the fining agent, particularly this clay and earth, they may, one has to take care that they may adversely affect the sensory characteristics of the juice. Similarly, chemical fining agents like gelatin and casein are used to clarify fruit juices, and they act partly to neutralize the electrical charge particles and partly by forming insoluble precipitate with the constituents of the juice. Gelatin combines with the tannins and casein combines with the acid of the juice. The gelatin may cause juice cloudy, however, if it is used in excess amount. So, depending upon the amount of tannins present in the juice, amount of the acid and other materials present in the juice, gelatin and this casein quantity should be used, and after it is mixed, the juice is allowed to stand for about 18 to 24 hours to ensure that the precipitated matter clots together and settles down, and the clarified juice is then siphoned off. Sometimes even albumin, egg white, is also used for clarification of the juices. So, this was a brief about that is various technologies. We discussed the extraction of the juices, even how we can use novel technologies to extract the juice and get more juice yield or even better bioactives, etc. And then finally, this juice that is clarified, that is either using physical methods or chemical method, they should be clarified. Depending upon the clarification process will depend upon the what type of juice. That initially we discussed that whether you want a completely transparent juice or cloudy juice or juice having some pulpy materials, etc. That is because these consumers, they like different types of, because anyway these pulps, etc., which might be present in the juice, they are also part of the fruit and they are completely edible. So, one has to take care accordingly. Appropriate processes should be used for making the juices and their clarification. And this clarified juices or even prepared juices have become very, very popular refreshing drinks. In nowadays, the consumers demand has increased, particularly in the recent past, and also this has got a lot of favor by the industry. There are a lot of such products available in the market nowadays. So, this is the references for this lecture. With this, thank you very much for your patience here. Thank you.